All right. Whoop. Thank you. All right. Hey, everybody. It's good to be here. Really great to be in Italy for the first time since I was a child. First time in Verona. First time to Pragma Mark. I'm really, really glad to be here. I want to thank especially the organizers and everybody who's working so hard. Aren't they great? Give them a round of applause. So I'm Jon Reid. You may know me from Twitter as Q Coding, which is short for Quality Coding, which is my blog. But I'm also starting to make my first steps into training and hopefully consulting. And some of you were the brave people to come to my TDD workshop a couple days ago. And I really want to thank you, these people. They were very brave, braver than I think they knew they had to be, because when I said hands-on, that meant hands-on at my computer in front of everybody else doing TDD. So very brave, and thank you very much. Let's, yeah. So kind of going off, I feel like in some ways I'm continuing what Krzysztof started, or maybe digging a little deeper into a question of architecture. And with Krzysztof's help, we're going to get away from doing this, right? Having the big monolith of a program. And in some ways, I feel like our journey, each of our journeys as programmers, we go through sort of the history of programming. We have to do it ourselves. So we start off with a monolith, and then we learn that that's not so good, and we start to break it down, and we learn things that have been taught to us by people much smarter who have come much earlier than we have, who started telling us about things like three-tier architecture or multi-tier architecture. This, even if you've never heard of multi-tier architecture, this should look very sensible. It just makes sense because we all are used to this. And this is repeating a sort of a sub-theme that I feel is coming up at this conference, and that is a separation of concerns, right? Very important. So how do we apply this? How do we usually do this? Or how does Apple tell us to do this? It usually ends up looking like, well, UI, well, that's dealing with the view, and that's talking to the user. The domain logic, well, all our domain logic goes into the controller because that's easy, and that's talking to the view. And the data access, well, that's the model, so that goes there. And it all seems to look very nice and very clean, except the controller really needs to initiate some conversations with our services and make some requests, okay. And really in view controllers, the controller is interacting, taking actions from the user, right? Okay, and how about the view and the model? Well, they're actually very closely related to each other. So this is now starting to look not so great. Oh, let's fix it. We're back to the monolith. This is why we have this joke from Colin at Facebook, who started the meme, I think. What's wrong with this? I mean, did the great architects of the past let us down? Are they wrong? Is the inventor of MVC wrong? No, they're not wrong. I think we were doing it wrong, in part because, as Krzysztof said, MVC is not an application architecture. It is a UI architecture, okay? It's the GUI. If we try to apply it too broadly, that's where we get in trouble. And that's why we need things like routers and so forth. Let's dig a little more into Model View Controller. And, well, really, I want to show you Model View Presenter. The presenter comes in. A problem with Model View Controller is that the view controller is talking to the views, okay, that's its job. but it is also coordinating information from the model. Okay, so it knows about two things, and it's kind of unfortunate that it knows about the model. So let's introduce a thing in between the presenter. Now the presenter knows about the model. The view controller and the presenter, they're very close together. But now the view controller is ignorant of the model. It is separated. Now you probably will look at this and say, well, that looks just like model view view model, right? The boxes are all the same. In fact, they are. And this is where when you're looking at design patterns, it's important to not just look at the boxes, but at the explanations behind them. Because the boxes look the same. But in fact, most of you are probably doing view model or something like it, where you say, I don't want to give it the full object from my domain. I would just try to give it basic information like strings, numbers, images, maybe some state about what is and is not showing. Very good. But how does this coordination usually work? You have to write binding of some kind from the view model to the view controller. And you can do this by hand. This can get tedious. That is why KVO is pretty popular for this. It makes sense. Key value observing, where you just have the view controller observing the fields in the view model and updating itself as things change. Great. And people like this because it saves typing. And then they say, well, let's do this some more, because the view model really should update automatically from the model. And why not? And now it's starting to get a little harder. And I'm not saying that you're doing this, but I have seen cases where the model itself was also doing key value observing of something else to get, for example, the either cached data or data from the network, and it would update automatically through KVO. Okay? So what we have is KVO, KVO, KVO in this great chain, and at every point going through the worst possible abstraction, a single method. It's like the most anti-object-oriented thing you can do. And every time something changes, it like propagates a little change, one field at a time, which propagates one change, one more field, or makes a few changes in the view controller, and then comes back, and then it gets another field, and it bounces back and forth. And if you tried to debug this, whoo, it gets exciting. So this is actually probably not the topic of this talk, but it's probably a good lead-in for other people to talk about functional reactive programming as probably a saner way to manage this. But let's talk about Model View Presenter, and I'm going to share this so that you have one more tool. We like to have lots of tools from which we can choose. So what is happening in the presenter, I will show you. But first, let's talk about this, the dependency, that the presenter and the view controller know about each other. That's not good. Let's break this up. What do we do with the bidirectional dependency? We fall back on the solid principles, specifically the D of solid, dependency inversion. Dependency inversion teaches us that we can still have the view controller looking at the presenter, but to get back to the view controller, we do not point directly at it. Instead, we point at an abstraction. This is the main thing about the dependency inversion principle, is to depend not upon something concrete, but upon something abstract. And so we introduce a protocol. Yay, protocols. The view controller then, of course, just simply implements that protocol. And so now you can see how we can have, in a safe way, sort of the arrows going both ways without creating a circular dependency. What actually goes on in the presenter? To explain this, I'm going to reach back into my past, about 3 years ago, when I was working at eBay. Now I am working at American Express, yay. But back at eBay, I worked on an app called eBay Fashion. And instead of just being, well, I should say, in addition to being normal eBay like you use, where I sell something to you, you sell something to me, they also had these sale items by special vendors to have items that had limited time or limited number, so it could be sold out. And of course, this is all just sales psychology to get you to buy more, because if it's, oh no, we're running out of time, oh no, we're running out of quantity, I must buy it now. So yeah, it's all good. If we tap on the left cell, what it would show is the name of the item, the price, and oh my gosh, it was originally $795, but it's 91% off, crazy, crazy. And so these things are added on to the original view, which would just have the title and the price, also the button to get more information. If we tap on the sold out item, it's very similar, except that the label at the bottom now, instead of saying 91% off, says sold out. So how does this work? I simply took an existing thing that showed an ordinary item, and I added 3 outlets to it. The sold out stamp that you see across the watch there, sold out. So that's one. The strike-through price label, that's the $795 US dollars there. The badge label, that's the 3rd label. Naming is hard. I'm sorry. That wasn't a very good name. We're not going to worry about all of these. I'm just going to focus on one item, and that is the strike-through price. So let's just pretend that that is the only thing we have. What does this look like in the view controller? How do we manage it? This is our naive implementation, where we just have a property that is the eBay item, and when it is set, it asks some questions. It says, does the item have a savings rate? If so, then get the list price for the item, convert that into a string, and set that in the strike-through price label, and make sure that label is not hidden. Otherwise, right, it will hide it. If there is no savings, don't put that in. Very easy. But remember, this is just one of the outlets. I've stripped out all the other stuff, so we're just focusing on one example. I'm lying. This is what it looked like. This is 3 years ago in Objective-C. It was not in Swift. The code's the same, of course. But one interesting difference between Objective-C and Swift is this. Everything in Objective-C has to be imported to have headers available so that you have definitions of the classes that you are sending messages to. In Swift, we just import the module, you have everything, and you don't worry about it. On the one hand, that's very convenient and nice. On the other hand, this gave me a clue with Objective-C that and you can go, if you still have Objective-C view controllers, you can check this in your sources to say, does it import the model? This is our goal, is to eliminate that import. As soon as you can eliminate it, you know that the view controller has no knowledge of the model, okay? Another nice thing that I sort of miss about having to manage all my headers is this. Run obj-c-dep, it's a nice little tool, and it scans through Objective-C source files looking simply at import statements. It is not doing syntactic analysis of the language, it's just looking at the imports, and it's putting together this graph and saying what depends on what, and if there are 2 things that depend on each other, it'll draw them with a blue line, which means that's really, really bad. And start to clean this up, okay? This is you can't reuse anything from here, because if you pull one thing, you get everything. This is probably a great audience to ask if somebody could start to write something like this for Swift. That would be great. It would be very helpful for us to be able to see what does this actually depend on. So, back to Model View Presenter.
Is this a command line function?
This is obfcdep is you can just look it up. I have links in my show notes, but it's just a handy little tool out there in open source. So first, back to Model View Presenter. Let's set up this structure. We have to have this relationship between these sort of this triangle that you see. And that's easy to do in Swift. In fact, it's easier to do in Swift than it was before. We just have create the presenter. The view controller passes itself in. The presenter keeps it, but not the concrete object. Instead, it is looking at the protocol, which we will define there and fill out eventually. Right now it's empty. And we say that the view controller extends that protocol. Easy. What we want to do now is move stuff. We want to get stuff out of the view controller. And we're going to perform a variation of extract class, the extract class refactoring. Now you may be thinking, John, I don't remember ever seeing extract class in Xcode. You're right. In fact, it's not even in app code. I do hope that JetBrains brings it to us because it is in their other tools. So we'll see. They're playing catch up as fast as they can with app code. But their refactoring is definitely superior. But you will still not see extract class. So what is this? I mean, how can you have a refactoring when you don't have a tool to do it for you? You go by the book. You follow the book. The book explains so many refactorings from very small things like rename function to larger things such as changing from switch statements to getting away from a switch statement. And interestingly, chapter 1 of the refactoring book says, whenever I do refactoring, the first step is always the same. I need to build a solid set of tests. For that section of code, the tests are essential. Each refactoring in the book lists a series of steps to follow. It says, change this, bring this over, run the test, make this other change, run the test, make this other change, run the test. The tests come into play very often and are very important. If you don't have unit tests to verify your refactoring, you are on dangerous ground. You may be refactoring. Sorry. Another thing I want to say about refactoring is that it's a very popular term to say, oh, I'm refactoring this. Chances are you're not. When I hear most people say you're refactoring something, actually you're rewriting it. That's a different thing. That's not a bad thing, but it's different. Refactoring is very precise about not changing external behavior and ensuring that through unit tests. And when you're refactoring with your unit tests in play, it's very important that you go from green to green without going through red. If you step into red, back out. That means you've made a mistake. Sometimes you start a refactoring and you say, I've gone red. I need to make larger changes. Oh, that's okay. Step back and do some more smaller refactorings, and then you can take that bigger step and stay green. But always stay green when you're refactoring. So let's do some. Actually, what I'm going to show you for refactoring is not the actual steps, but the end result. Here is our method, our did set, and this is what I want it to become. I simply want it to tell the presenter, hey, present the strike-through price for this item. Okay? So everything in there is going to move over. What does it move to? Over in the presenter, it looks like this. You notice the shape is the same. Some of the insides are a little different, but the shape is the same because I just basically brought that over, and that's important. Recognizing shapes is a good skill. It does have some differences in that it is not speaking to the strike-through price label. It doesn't know about that. The presenter doesn't know about the actual controls and views. It does know to ask the protocol, show the strike-through price with this text, or hide it, which makes the view controller really easy. Look at this. Super simple, right? And there's not much to say about this. This has become so simple, it's almost not worth having tests for, but I still want them. It is using now tell, don't ask. That is, the view controller is no longer asking the item anything. It can still receive the item, but it won't ask it anything. It was not making any queries. Instead, it's just being told what to do. Show this, hide this. The actual steps involved in this refactoring were to first create the presenter class and set up the empty view protocol and link them together like I showed you. And then start doing extract method. That's another refactoring. Starting at the bottom level, sort of the most low-level things of dealing with show the strike-through price, hide the strike-through price. So I extract those first. And then, once those are out of the way, I can extract the present strike-through price method, but it's still inside of the same view controller, okay? I haven't moved it. I'm not going crazy here. One thing about refactoring is you can work in very small steps. Once it's extracted, then I can do the move method refactoring. Each of these is in the book, and when you go look up the book, and I just took a picture of my book, if we look at, for example, the move method, this gives you an idea of the structure of the book, is that it gives you the name of the refactoring, a quick explanation, a diagram, a section on motivation. What is it for? Why would you want to do this? And then a list of mechanics. These are the steps to follow. 15 years after buying this book, this is still the book that I pull off my shelf more than any other for daily use. It's like, oh, I need to do this. I need something to remind me. What are the steps? Let's do a little more refactoring. This is what our presenter looks like now. It looks very clean, very small, but my eye now looks at things like conditionals. If there's an if statement, I start to and some things in there, I start to ask myself, isn't that something that can be extracted as a method, even the conditional alone? You may think that's excessive, but I think it's cleaner. And when we do that, actually it gives us a clue that, oh, that's the part that's actually querying the item. There's something else that queries the item. In fact, let's take all the things that query the item and pull them out and extract them into helpers. So you see, we've got a simple helper is on sale. We have another helper list price. They may not stay here. This may not be the right place for them, but it is a first step. Perhaps they need to move closer to the model. Maybe they can be part of the model. Maybe they become extensions of the model. I don't know. I'm not going to worry about that right now. But what we've done by taking this step is we have made a big step forward towards domain-driven design. This is not an easy book to read, but it will bend your head and cause you to look at your code differently. In particular, one of the key themes of this book is that as developers, we recognize concepts that are hinted at in the discussion or present implicitly in the design and make them explicit. We take implicit concepts and we make them explicit. This is very important. If we go back here and ignore the helpers and just focus on the main present method, this is something that I can sit down and have a conversation with the product owner about. Okay, the product owner may not be able to read the code, but I can say it in English or whatever you have. I can say, when it comes time to present the strike-through price, we check, is the item on sale? And if so, I'm going to show a strike-through price with that item's list price. Otherwise, if it's not on sale, I'm going to hide the strike-through price. Is that correct? And the product owner can say yes or no, right? And this is important not just for confirmation with the product owner, but for expanding the expression of our domains. Each of our domains is different. There's knowledge and details about our domains that is very important, I think, to express in code with proper names so that not just with the product owners, but as a larger team, we can have a shared understanding of what it is that we are doing and what we're manipulating. So, here's where we started. Just a view controller with a did set that's talking to the strike-through price label. Here is where we ended. Now this may look a little more complicated. It is. But what has happened is now the did set talks to the presenter. It still takes, you notice the did set in the view controller is still taking the item, the eBay item. That has not changed. Very curious. This is a big difference between MVP and MVVM, is that with MVP, I don't have to change the interface of the view controller. That can stay the same. All I've done basically is some hidden stuff. So that talks to the presenter and asks the presenter, please present the strike-through price, which talks to the protocol and says either show or hide the strike-through price, which then comes down through the chain to actually talk to the strike-through price label. So this is a trampoline pattern, you know, boing, boing. Some of the benefits of this, the model, the transformation of the model into a view becomes explicit. Maybe I'm just old school and I just like to type a lot, but I like things that are clearly tied together. And again, this is where probably the alternate path of functional reactive programming is also clear, as long as you can read it. But it makes these transformations explicit. It makes the domain concepts explicit, as I just showed you. You don't have to do this, right? This is one thing. What I just showed you is another option. It's just another tool for you to consider. Our friends over in other development lands are much more familiar with Model View Presenter than iOS folks, but I'm bringing it in to show you. Here's another tool. So you don't have to decide up front, I'm going to do everything this way. You don't have to decide, I'm going to do everything even with MVVM. We can selectively change view controllers one at a time to improve them. But maybe the hidden message of this presentation, maybe the point that I didn't realize when I was writing this was actually the big point, is refactor, really get better at this. And that everything that I showed you could be done with refactoring. I think to transform something to MVVM, it could also be done. It would just be a little different because I think there are ways to do it, to sort of hide the view model part within the view controller and then swap it out. There's got to be a way to do it. Use refactoring. It'll keep you sane. We follow these steps. Our view controllers become cleaner. Your life becomes better.